Hey guys, in this video we're going to look at expected value for an outcome of events, and also use that to calculate fair price for events. So we'll dig into both of these a little bit. So first, expected value is used to determine the expected results of an experiment if you repeat it many times. For example, flipping a coin 1,000 times, you would expect about 500 heads, 500 tails, something like that. Expected value is used to make important decisions in many different areas. For example, businesses will use it to predict future profits. Insurance companies use it to determine prices for policies and things like that. It's also used to predict gains and losses, like how much money maybe a casino would make and things like that. Or if you are playing one of those games, you could kind of figure out your expected gains or losses. So, formula for expected value is, we'll dig into it here, but when there are many different events and amounts, you use the formula where P is the probability and A is the amount won or lost. So you take the probability times the amount, probability times the amount, probability times amount for as many different things as there are. So you first find the probability of each possible outcome and then multiply it by the amount gained or lost. And you find the sum of those products. So Teresa's taking a multiple choice test in which there are 4 possible answers. The instructor indicated that she will be awarded 3 points for each correct answer, and she will lose 1 point for each incorrect answer, and no points will be awarded or subtracted for answers left blank. If Teresa does not know the correct answer to a question, is it in her advantage or disadvantage to guess? So again, there's no penalty for leaving it blank. There is a penalty for getting it wrong, and there's a gain for getting it right. So remember, our equation was E equals P times A over and over and over again, where P is the probability and A is the amount gained or lost. So the probability of getting it correct is 1 out of 4 if she's guessing, because there's 4 possible answers for each question. So that's the probability, and then the advantage would be 3 for getting it correct, 3 points for getting it correct. And then the probability of getting it wrong would be 3 out of 4, and the amount would be a 1 point deduction, so it's going to be -1 for that. So this is 3 times 1/4, that's 3/4. This is -3/4. That equals 0. So is it the advantage or disadvantage to guess? Neither. It's actually a break even on this one because it equals 0. If it was positive, that would mean it would be in her advantage. If it was negative, it would be a disadvantage. But it's weighted appropriately so that it's neither an advantage or disadvantage. If she can eliminate one of the choices, is it in her advantage or disadvantage to guess? So now she eliminated one. She knows it's not correct, which means now she has a 1 out of 3 chance of getting it correct and getting those 3 points. And she has a 2 out of 3 chance of getting it wrong and losing a point. So if we did that, we get 3 times 1/3 is 1, plus -2/3. Subtract that, you get 1/3. So it's positive, so that means every time she's able to eliminate one, she has the expected value of getting 1/3 of a point, or 1/3 of those correct. So it's positive, which means it is an advantage. So it is an advantage to guess, yes. And here I'll write down neither because it was a tie. So in a full sentence way of answering that question, she will gain an average of 1/3 of a point each time she guesses if she can eliminate one of the choices. That'd be a bigger advantage if she could eliminate two. We could calculate that the same way, but let's move on. Let's look at another example. John and Jen play a game. John picks a card from the deck. If he picks a club, Jen gives him $4. If not, he gives her $2. Determine John's expectation. So the probabilities are picking a club or not picking a club. So clubs, that's 1 out of 4 of the suits. And every time he does that, Jen gives him $4. It's like a plus $4. And then the rest of the time, the other 3 suits, 3/4 of the time, he would lose $2. So I'm multiplying this out. 4 times 1/4 is 1, plus 3 times -2, and then divide by 4. You can use a calculator for that, but that works out to be -1.5. So this is -0.5. So what that means is his expectation is for every round that he plays, he's basically expected to lose 50 cents. Now we can look at it the other way, and maybe you could just use a little common sense and come up with the answer. But Jen's expectance would be that 3/4 of the time she will gain $2, and 1/4 of the time she will lose $4. So the math really is going to work out the same here. This is going to be 1.5, and this is going to be -1. So hers would be a plus 50 cents, plus 0.5 or 50 cents. So again, in context, that means that for every round that they play this game, every time he draws a card, John's expecting to lose 50 cents, which means Jen is expected to gain 50 cents. All right, you're given an opportunity, or somebody's given an opportunity to purchase a ticket for $75 door prize. The cost is $3. There's 150 tickets. Determine the expectation if he purchases one ticket. So if he does just one ticket, it's 1 out of 150 odds that he would win, and if he wins, he gets $75. The cost of the ticket is $3. And let's see, the cost is $3. So now we look at the rest of the time. He's not going to win. So that's 149 out of 150 times he will not win. If he doesn't win, then he is out his $3. Now, technically, I'm going to work it out this way, but technically this should be a 72, because no matter, like, if he wins the 75, he doesn't get his $3 back and the $75. So technically that's a little bit different, but I'll work it out this way because that's the way I know I have it on the answer key. But an argument can definitely be made that that should be a 72 instead of a 75. Or that should be a 0 then, but it really should be a -3. I agree with that. So, all right, so let's multiply these out. $75 times 1 divided by 150 is 0.5. plus 149 times -3 divided by 150 is -2.98. Plus that 0.5 would be an whoops, negative. Didn't get the decimal point in there. Plus 0.5. 248, -248. So that's the expectation. If we were to change this, because really, I think you can argue that it wouldn't be winning 75, he'd only be winning 72 because he lost the cost of his ticket in it. We can change that number there, so that's 72 divided by 150. .48. This one doesn't change, so that'll be minus 2.98. That'd be minus 2.5 there. So either way, really not a great expectation. You wouldn't want to do this. This is not favorable either way. It's only a minor difference if you account for the $3. So an outdoor vendor sells an average of 50 hot dogs per day and 15 when it rains. So when it's dry, 50, and when it rains, only 15. If it rains 25% of the time, determine the expected number of hot dogs sold per day. So it rains 25% of the time, so 25% of the time they're going to sell 15, and then the rest of the time, 75% of the time, they will sell 50. So we multiply them out. Now we need to add them up. $41.25. So based off of that, it means that the average is a little bit over 41 hot dogs a day per average. So that would be used to figure out, like, if they charge a certain amount of money or if they made a certain amount of money for each hot dog, to figure out how much they could make in a year, just figuring out the per day number of hot dogs on average, basically, that they sell. So the fair price is the amount to be paid that would result in no loss. So where our E would equal 0 at the end. That's what makes it would be fair. Typically, like I was saying before about casino games and things like that, it will be a gain for the casino because it's a business. They have employees to pay and things like that, which means that even to be break even, they have to make sure the games are in their favor, sort of thing. So we calculate it by adding the cost to play with the expected value. And that's how we get the fair price. So fair price is the expected value plus the cost. And we said, to be fair, that should be 0.
I'm trying to find out what to do.
All right, so suppose we're playing a game when you spin the pointer or a spinner, and you're awarded the amount shown under the pointer. It costs $10 to play the game. We're going to determine the expectation of the person who plays the game. So if you were playing this game, we're going to figure out the expectation. So for this, we're going to assume that these are all kind of cut in half. So that means that for probability of getting, well, let's figure out each of these things together. This would be, each of these would be like a fourth, well, a fourth of a half, so I mean an eighth. This would be 1/4 of the full circle, and this is 1/4 of the full circle. So the probability of getting a $2 would be the 1/4 plus the 1/8. And that's 3/8, or if you wanted a decimal there, you could get the decimal from it. We'll make our math a little bit easier. We'll just call this 2/8 and 2/8 and make our math easier for everything else. So for $10, it's going to be the same thing. We've got a 1/8 and a 2/8, so that again is 3/8. For $15, that's just the one section, so 1/8. And then for $20, same thing, one section is 1/8. So we're going to figure out the expectation for each of this. So this is doing the amount won loss. So this is for like each part. This is our probability times the amount for each part. So that would be 6/8. Yes, that can reduce, but that's okay. This would be 30/8. 15/8, and then 20/8. So if you play the game, you are expected to add all of these up. If you play, you expect to get this much. So that's all over 8, so let's just add the numerator. 6 plus 30 plus 15 plus 20, 71. So we'll do divided by 8. That'll be 8.875. That's your expected amount to win by playing once, but you got to remember that you are paying $10, so let's subtract the $10 from it. We can do that at the end here. So we'll take that and we'll subtract the $10, and that is negative 1.125. So that was a little bit different than what the way we did it on that last example when we had the cost to buy the ticket. What I could have done differently would have been more like the last time we did it, is if you look at it as doing it all in one step, really. If you paid $10, that means that if you only won 2, you really lost $8. Here you won nothing, so that'd be 0. Here you win $5 because you have to, if you subtract the cost of the ticket from each step. Or, like I said, you could subtract it at the end like we did here. So either way would work out. You get the exact same answer both ways. But what this says is, it is every time you spin, you're expected to lose a little bit over $1. Which, again, that's a little bit, means that they're priced a little bit above the fair price, basically, is what we were talking about in that last slide. The fair price would have been this first amount that we had right here. Would have made that be 0, which 71 over 8 is 8.875. 8.875, we'd have to round that up to $8.88. All right, that's it. Find your homework in the Files tab, get it submitted, and post your comments and questions. See you guys next time.